Okay, for today we're going to be talking about inferring and evaluating. So to infer or evaluate, we need data, and that is very important to understand both the difference between inferring and evaluating, and also knowing how to make inferences and how to evaluate. Now, before we get started, inferring, we're going to learn about that in a bit. And I'll tell you the difference between the two. But we're just going to talk about convincing arguments, because arguments are what you're going to make, whether it's an inference or evaluating. So here we have an example. The school cafeteria collected data on the numbers of hot chocolate cups purchased by girls and boys during the first 15 days of September. So you can see that there. All right. So the girls bought 63, the boys bought 74. Amy used the data in this table to argue that boys drink more hot chocolate than girls. Okay, so that's what Amy is saying. Amy is saying that this data here tells me that boys drink more hot chocolate than girls. Alice said that there was not enough data to make that argument. So the students collected more data to test Amy's argument. So you can see that they collected the data over 5 months instead of just 15 days. And if you look over here, you'll see that it's 863 for boys, 868 for boys, 863 for girls. So Amy is saying her conclusion was correct because the total number of hot chocolates purchased by girls was 863. This is less than the 868, which is the total for boys. Alice looked at the data and made this argument that more students drink hot chocolate when the weather is cold than when the weather is hot. And if we look back here, we'll see that the numbers are lower in September than they are in, say, January. So yes, that might check out. Which of those two arguments are more convincing? Alice's argument is more convincing than Amy's because in 5 months, the total sales for boys was only 5 more than the total sales for girls. Those numbers are not that far apart to be convincing. So Amy's argument is not great, whereas Alice's argument is a little bit more convincing because the numbers are more than 100 apart. So you can see that there's absolutely an argument that hot chocolate would be purchased more in the winter, which also logically makes sense. So when we're making an inference, we use data to predict a value in the future or to estimate a value between given data. We make that inference. When we use data to make a conclusion, we infer. So an inference is something where we take the data that we know and we suggest something that could be true. So it doesn't necessarily pan out all the time. So like I could say, okay, so it's been 0 degrees every day this week. I think that it'll be 0 degrees every day next week. And then all of a sudden it gets freezing cold and it's minus 20 outside. So my prediction is completely wrong. But I made an inference based on the data that I had. Next, you could do the other part of this, which is evaluating. And when you evaluate, you're just looking at the data and you're saying things that you see. And we're going to see that here in the next slides. So an inference is where you're making a guess, an educated guess as to what's happening. And evaluating is just saying a conclusion you draw from the data. So we have a double bar graph here. Oh, where'd it go? It'll pop up here in a second. Hello, Mr. Double Bar Graph. It's there. I see it. Where are you? There it is. Okay, let's go back here. And we're loading. We're still loading. Oh my goodness, this is just so slow today. I'm going to go from this screen. All right, so the percentage of employees, I'll slow down. This double bar graph shows hourly wages of Canadians from 1997 and 2003. So each argument is us evaluating the graph. And we're going to see how we can prove it is true. Because when you make an argument, you can't just say something like, the sky will be purple tomorrow, and everybody's just supposed to take you at your word. It doesn't work that way. We need to prove ourselves. So the percent of employees who earned under $8 an hour decreased from 1997 to 2003. So to prove that, we would say, I know this because if I look at the data of under $8, the bar for 1997 is larger by 3 than the bar that's in green. So that is me justifying my argument, and I'm evaluating this graph. All right. And then we look over here. Approximately 50% of employees earned $16 an hour or more in 2003. So how do I prove that? Well, I'm going to have to count it up. So I start here at the $16 an hour mark where we have 15. And then it goes up here to this one. We're going to add this bar in, which looks like it's about 12, I would say. So 15 plus 12 brings us up to 27. And this one looks like it's about 9, so that's 36. And this one looks about 9 as well, which brings us up to 45. And then we have what looks like 6 here, so that brings us up to 51. So approximately 50% of employees, earned $16 an hour or more in 2003. And we know this because we added it up and it equals 51%. And the solutions are here as well. You can see this would be a level 4 answer if we were looking at a test. So if I made those statements and I needed to justify, the bar for the interval under $8 is shorter for 2003 than it is for 1997. This means that there was a decrease in the percent of employees who earned less than $8 an hour from 1997 to 2003. And then this one added up everything. You can see that level 4 answer. So to practice, you're going to be doing pages 196, numbers 1 to 5, and number 7. If you have any questions, make sure you come to today's meet at